So this video picks up where the part studio on gear trains left off. We're going to now create the assembly of the gear train. So let's go back into our Onshape model. This is the one we are working with. Hopefully you have the right size holes through the center of the gears. Maybe your back plates been prettied up a bit rather than just being rectangular. But let's create, and I also would like you to name your part studio as well as the parts in your part studio, but let's create an assembly. And let's just insert, I think it's safe to assume insert everything from this part studio. That's a decision you have to make, if that makes sense. And I'm gonna fix my back plate. Okay, so first we're gonna add some revolute mates. I'm gonna add a revolute mate between the plate and the gears. Sometimes the trick is just getting the right one here. So maybe I'll just come in and hide this one then. And I think I might have gotten it wrong. Oh no, it's just because it's hidden. Let's see. Yep. And now let's just do a revolute mate again here. Don't forget you can hit your shift key to make sure you're getting the mate connector from the surface that you want. Okay, and so now, one of these gears is thicker than the other. We'll deal with that later. So, as you can see, this moves and this moves into, one second. And so obviously this revolute did not go well. Oh, there's somehow nothing in there. So let's go back in, make sure I get this picked. I want the back of that with the front of this hole. There we go. Okay. Now I can spin these independently. Okay. Now, the last thing you want to do now that you've added these revolutes, which is just saying the gear can spin on the hole, is you actually need to put a relationship between these two gears. And to do that, you actually pick the two revolutes that make up those two gears. And you can see now that they are not aligned. Let's see. They are moving in the right direction, though. So when one spins clockwise, the other one spins the right direction. So the relationship here, let's see, this one's a 40 tooth and this is a 20 if I'm remembering correctly. So that should be a ratio of 2. And let's give that a try. And there we have it. And those are meshing what looks like perfectly. Which is unfortunate because I actually wanted to simulate how you fix it. So let me go through the train. I'm going to pause the video and I'll come back and all these will be mated. Okay, I'm back. I just added the revolutes and renamed them so that they're easier to follow. And now what I want to do is drive this to that. And you'll notice what you have to do is you have to make sure you pick the revolute from the specific gear. This is again going to be, I think it was 2. And let's see if that goes right. Yep. And the last one is this gear. We're going to pick the drop. No, we're going to pick the C gear to the D gear. And this should be 1/3. And you'll see that it is also going the right direction. So we lucked out in that. But let me just show you. If you needed to flip the direction, you simply, wrong one. I'm going to come into the gear and you say reverse direction. And then if one's going clockwise, it will reverse that. But now you can see these line up quite nicely, whereas these teeth are literally inside of each other. So to fix that, you pick on one of your gear or your revolute mates and then edit the mate connector. And I'm just going to say move, rotate about Z, And this is your rotation angle. This is a little bit of guess and check. So I'm going to say 5 degrees. That's not far enough. 15 degrees is looking pretty good. So I'm going to hit the green check. Now, the last thing you can do is drop this down and say interference detection. Now, we're eyeballing it here, but if we say interference detection and then you zoom out and you pick the two gears, it will highlight in red if there is any interference. And wow, I think I got really lucky there. So let me change this just so that I can illustrate it. Sorry, so I'm going to edit the initial starting point and say 14.5 maybe. Oh, I guess you can use your mouse to move this too. And that's obviously wrong, but maybe if you zoom out, you don't quite see it as much. And I say interference detection again. You have to tell it interference between what and what. Now if you zoom in, you can see that it'll highlight that in red. And it's an iterative process, so you just go through and you pick it again. And I happen to remember that 15 seemed to really nail it, so let's try this again. Interference detection between that. And now I don't see any red even when I zoom in very close. So that means our gears are all lined up. One thing that's important to note too is if, for whatever reason, your gears get misaligned, you can always come over and say reset on all of these, and it'll give you back to an initial starting position. And they're all, as you saw, move together once you reset one of them. So that's it. That shows you how to create the CAD model of your gear train.